Welcome. In the last lecture, we have defined the Fourier coefficient. Let us recall that this is a map we are considering to C complex function, and then we denote the Fourier coefficient as the capital F, which is 1 over n, summation over n equal to 0 to n minus 1 f of n e to the power minus 2 pi I k by k n by n. Okay. So, then easily one can see that some basic properties if f and g are Fourier coefficient of functions f and g respectively, then f plus g is the Fourier coefficient of f plus g. That is just the linearity of the sum is going to give us this much, because suppose h of k, the Fourier coefficient of f plus g, this is 1 by n, n equal to 0 to n minus of 1, f plus g of n e to the power minus 2 pi I k n by n. Then this is, if you split the sum, you are going to get f of k plus g of k. Okay. So, in general, if f j from z n to c and j is equal to 1 to some m, then the Fourier coefficient of summation over j from 1 to m f j is given by summation over j from 1 to m f j. That means individual Fourier coefficients, they get added. Then the second one is that let g of n, this is equal to f of capital N minus of n, where f is a function from z n to c, and I define, then g becomes a function also from z n to c. So therefore, the Fourier coefficient of this is, if you do it g k, the Fourier coefficient of g, then this is going to be 1 by n g of n e to the power minus 2 pi I k n by n, which is equal to 1 by n summation over n equal to 0 to n minus 1 f of n minus of n e to the power minus 2 pi I k n by n. Now, of course, so if I make a change of variable that capital of n minus of n is equal to L, then this L is going to vary from 0 to n minus 1 again, right. And so, therefore, this is, we can get n L equal to 0 to n minus of 1 f of L e to the power minus 2 pi I k, and this n is replaced by, this n is replaced by L n minus of L by n, because I am taking n minus of n, this is equal to L. So, therefore, this is 1 by n summation over L equal to 0 to n minus 1 f of L e to the power 2 pi I k L by n, because again by the by periodicity of this. So, this is equal to f the Fourier transform at minus k. So, remember that minus k in my notation is the inverse of the k in Z n, that is the n minus k. So, that is what is one can see, and then the second is, so if we take third, you take G n to be equal to f n bar, then of course, what you can get this G k, then you can take the bar outside the sum. So, e to the power, so this is summation n equal to 0 to n minus of 1 f n bar e to the power minus 2 pi I k n by n. Now, if I take the bar whole outside n minus of 1, then this is f n e to the power 2 pi I k n by n, and this. So, again this is equal to 1 f minus of k bar. So, now one of the thing what we observed in the Fourier transform in the Fourier series case is that if I translate, then I take the Fourier transform, then it was heated by a character. So, similar kind of thing is going to be true over here. Now, you define g of n is equal to f of n minus of n naught for some fixed n naught. Then if you compute just like that, you are going to get g of k. This is equal to heated by the character, it is e to the power 2 pi I k n naught by n into f of k, because you can pull out the k times n naught by n, that will be independent of n in the sum variable. So, you can get that. So, and the converse is also true. Now, if you take g of n, you hit that with a character 2 pi I k 2 pi I n naught by n, g of n is n naught by n and f of n, then g of k, this you are going to get that this is f of k minus n naught. Just you take the sum inside, then what you are going to get is this. Okay. So, now another important property what we have exploited in the Fourier series case, that is the convolution. So, now we can define the convolution. Let f g is from Z n to C, define f convolution of g at n, this is equal to 1 by n summation over j is equal to 0 to n minus of 1 f of n minus j g of j. As you can see that I can define actually f for any integer, because every integer is going to have a representative with respect to capital N in among the number 0 to n minus 1. As a matter of fact, they are equivalence class I can define. Each of them, suppose 0 is going to be the same as n, 2n, 3n, 4n, 5n, 6n, minus n, like this. 1 would be n plus 1, right, and then you are going to 2n plus 1, 3n plus 1, like this. So, therefore, there is absolutely no ambiguity in defining f of n minus of j. So, now there what we have seen when we did the convolution, there we found that actually there does not exist any g such that f convolution of g is equal to f for all f, because if I take the argument there was, if I take the Fourier transform, then what we get, that g hat of n is equal to 1, and which contradicts the Riemann-Lebesgue lemma. Let us see whether we have something here similar or we have something better. So, define g of n is equal to 1 if n is equal to 0, 0 otherwise. That is again delta 0. Then now f convolution of delta 0 at n, this is going to be 1 by n summation n equal to 0 to n minus 1 f of j delta 0 of n minus of j. As you can see here, because this is an abelian group, so I can I can take that this is also equal to n summation over j from 0 to n minus of 1 f of j g of n minus of j. So, there is nothing to, just a change of variable is going to give me this, and if this we can also, f convolution g is equal to g convolution of f. So, now here let us look at this. Now, the sum, this one is going to survive only when this n is equal to j. I mean, rather j is equal to n, because n is fixed. Here we have j equal to 0 to n minus of 1. So, whenever j is equal to n, then it is going to survive rest of the, for the rest of the j, this will be 0, this delta 0 would be 0. So, only term which gets survived is f of n. So, now if I do a little bit of this, if I define my g to be n times delta 0 of n, then that is g is taking the value n when n is equal to 0 and taking the value 0 when n is not equal to 0, then in that case what I get is, for this g at n, this is going to be 1, sorry, this is going to be f, because n is going to get heated, because this value is going to take the value capital N, therefore, what we are. So, here in contrast with the Fourier series, here what we have found is that it has an identity. Okay. So, now the next, one of the most important properties of the convolution we have used is the Fourier transform. Convolution we have seen as a product on the domain side and with the function side, then when I take the Fourier transform, it is going to take f hat to f hat, because it is pointwise multiplication. In Fourier similar kind of thing, let H be the Fourier transform of f convolution of G. So, let me write down then this h k, this is equal to 1 by n summation over n equal to 0 to n minus of 1 f convolution of G at n e to the power minus 2 pi I k n by n. Now, I will open up f convolution G. This is equal to 1 by n square is going to come out, which is equal to 0 to n minus of 1 f of j g of n minus of j e to the power minus 2 pi I k n by n. Now, first I will do the n sum. So, this is j equal to 0 to n minus of 1 f of j, then 1 by n summation over j is equal to 0 to n is equal to 0 to n minus 1 g of n minus j e to the power minus 2 pi I k n by n naught. Now, I make a change of variable n minus j. So, now here I am going to get an extra factor. So, this is going to get 1 by n summation over j from 0 to n minus 1 f of j e to the power minus 2 pi I k j by n into this is g of k. So, now the first quantity is nothing but f of k and g of k. So, exactly it follows that the Fourier transform of f convolution G is going to be the Fourier transform of f times the Fourier transform of G. Okay. So, now and then what we must try to get. So, the one of the most important thing there was that the inversion and the Planck's rule. So, now let us see that whether we are going to get this over here or not. Now, you consider V to be the set of all functions now. Of course, V is going to be a vector space, because if I take two functions, then some pointwise sum f plus g n is equal to f n plus g n, this is again a function, and if I hit that with a scalar, then that is again going to give us a function. So, V is a vector space. Now, if it is a vector space, then it must have basis element. So, what are the basis elements of this? So, now define E 0 of n, this E or rather E I of n this is equal to 1 if n equal to I and 0 otherwise, and this is for the function I from 0, I varies over this. For each I from 0 to n minus 1, I define this function. So, there are n types of n of this function. Now, these E i's linearly independent? As if you take I from 0 to n minus of 1, a I e I, this is equal to 0. That means, this is true for every n, for all n belongs to Z n. Then here only n it is going to survive is that I is equal to n. Therefore, alpha n is equal to 0 for all n. The a n is equal to 0 for all n. Therefore, they are linearly independent, and now one can see that if you take a function, let f is from Z n to C and f of n is equal to alpha n, then this f can be written as f of n, this is equal to summation over j from 0 to n minus of 1 alpha j e j of n. So, that basically says that this spans the whole thing. Therefore, the dimension of V is equal to n. Okay. So, now once we have a vector space, then it is natural for us to define the inner product in that vector space. Let f and g, this belongs to this vector space, then define the inner product f g, this is equal to 1 by n summation over n equal to 0 to n minus of 1 f of n g of n bar. And as usual, I will denote square, this is equal to f comma f, which is equal to 1 by n summation over n equal to 0 to n minus of 1 mod f n square. This is the so called norm. So, now what we need to find is that whether we have the inversion as and Parseval identity in this setting. Recall one thing, that in the Fourier series case, we have exploited that e to the power I n theta, they are going their orthogonal family, and with a scalar multiplication they become orthonormal, and that we have exploited heavily while doing the Fourier series. So, now let us see that the similar thing is going to be true here or not. So, let me write it as a lemma, the family E 0 to E n minus of 1 is an orthogonal family. The proof is trivial. What do I mean by the orthogonal family? Let me define it. That means E m E j, this is equal to 0 if m not equal to j. Moreover, E m this is equal to 1 by n. Now, let us do the proof. Proof is simple, just writing down the definition E m E j, this is equal to 1 by n summation over n equal to 0 to n minus of 1, and so this is actually, this is going to be equal to 1. So, this is E m of n E j of n. So, this is equal to 1 by n, and if, as you can see, that you are doing the pointwise evaluation of n is not equal to m, this is equal to 0, and if j, so only surviving term is going to occur is that provided it is going to be equal to 1 if m equal to j, if m is not equal to, and this is equal to 0 if m is not equal to j. Because if m is, wherever E m is going to take the value 1, E j is going to take the value 0, because m and j, they are not equal. Therefore, you are going to get that this is but this is an orthogonal family, but this is on the function side, which is actually not going to give any kind of result in the Fourier analysis, because we want to look at the orthogonal family in terms of on the Fourier side. That means, there we are looking at e to the power 2 pi I n theta. So, similarly define phi of n or phi k of n, this is equal to e to the power 2 pi I k n by n. Now, whether this is an orthogonal, this is a function and which is orthogonal in, so obviously, all these phi k, this belongs to V. Now, if I take phi k and phi j, this is equal to, by definition, 1 by n summation over n equal to 0 to n minus 1 phi k n and phi j n bar, which is equal to 1 by n summation k n by n into e to the power minus 2 pi I j n by n. This is equal to 1 by n summation over n equal to 0 to n minus of 1 e to the power 2 pi I k minus j of n by n. Now, if k is not equal to j, then these are all the nth root of unity. So, therefore, this if is equal to 0 if k is not equal to j. So, now this is an orthogonal family, this is, and this is what we are going to exploit to get results in this setting. Thank you.